Hello, everyone. Can you hear me? Yes, sounds like the microphone's on. Hi. So I'm Tim. Today I'm going to talk to you about server-side Swift and specifically with Vapor. Wake up. There we go. So a quick introduction before we get going. So I'm Tim. I'm a software engineer at the BBC. I work on the mobile playback team, and we make all of the frameworks that are common across all of the BBC's mobile applications for playing back media and to do with media consumption. So that could be the media player that plays back audio and video in iPlayer, Sounds, Kids, Children's, iPlayer Radio, to the library that manages your downloads, to the library that does DRM encryption. So we touch a lot of devices. I think our code's on about 97% of devices in the UK. And we also have quite a big worldwide base as well with things like news, sounds, and radio. So we manage a lot of devices and a lot of traffic, and I'm also responsible for all of the CI infrastructure for mobile apps at the BBC. So no pressure there. You can follow me on Twitter and GitHub and Slack and Discord as 0xtim if you want. If you want to get in touch afterwards, and that 0x is in the number and not the letter O. That seems to confuse a lot of people, but I think that's just me coming from my geek background of hacking hex. I also started a company called Broken Hands a couple of years ago to do kind of side projects and stuff like that. But these days it is all exclusively working on Vapor. So I do training courses and workshops, video stuff, and that's all Vapor through Broken Hands. I do a lot of open source projects with them as well. And you can find that on GitHub under the Broken Hands IO handle. So check that out. I'm also an author and instructor for raywendlick.com. So for those of you coming from the iOS mobile world, you probably know Ray Wendlick's site. It's great number of tutorials and really good quality content. So I do a lot of video and also write a book for them. And finally, I organize a number of meetups and stuff around the world. So I organized server-side.swift, which was the world's first server-side Swift conference. That was in Berlin in September. I also organise meetups in London and Manchester, and also one at DubDub every year. So that's pretty cool. We get loads of people there, which is awesome. So, what is Vapor? For those of you who've never heard of Vapor and don't know what it is, it's effectively a web framework for writing web applications, server applications, APIs in Swift. It's made up of a number of components. So you have Fluent, which is kind of the database abstraction layer, the ORM, and that handles everything interacting with the database, so you don't need to worry about much of that. And then it helps send and receive HTTP requests from clients or to other servers. And there's also a module called Leaf to enable to do HTML templating for some front-end stuff. So it basically provides all the building blocks you need to be able to use to write server applications in Swift. So Vapor was created in February 2016 by a guy called Tanner Nelson. And then he was joined pretty much straight away by a guy called Logan Wright. And that was almost straight after Swift was open sourced by Apple, which meant you could run it on Linux. It's followed a very similar development pattern to Swift. So with Swift 1, when Swift 1 came out, there was a lot of excitement around it. People started to use it. Then Swift 2 came out, and it changed a few things. It kind of learnt how it wanted to be as a language and develop as a language. And then Swift 3 came out, and it broke the world, and everyone got really annoyed. And then Swift 4 came out, and actually it wasn't that bad transitioning to Swift 4, and now people are a lot happier, and the APIs look a lot nicer because they're Swiftified and not kind of Objective-C. And Vapor's followed a very similar pattern. So Vapor 1 came out, there's a lot of interest around it. Vapor 2 came out, as it kind of worked out the limitations of the compiler and what kind of areas it wanted to go in. And then Vapor 3 came out, and it broke the world, and everyone got really annoyed as we moved to an asynchronous architecture. But now people are kind of getting on board and understanding it. And I suspect the move to Vapor 4, when that comes out with Swift 5, will be a lot simpler and a lot easier for people to understand. And Vapor is also built on top of Swift Neo. So Swift Neo is an asynchronous, non-blocking I/O framework written in Swift. It's very similar to Netty for Java. It's written by Apple. It's open sourced by Apple. It's on GitHub. All of the issues are on GitHub. All the pull requests are on GitHub. It's a lot better than Swift is because if you want to file an issue, you can just go to GitHub and file it there. The developers of the framework are very engaging with the community, so you can just hit them up on Twitter, on Discord, on Slack, and they'll help you and answer questions. And this allows Vapor to concentrate on providing a really nice kind of Swift API and framework, whereas Swift Neo handles all of the low-level kind of socket communication, HTTP parsing, all the low-level kind of non-blocking stuff, and especially event loops, which are kind of really gnarly, and you don't really want to be handling that as a framework. So we let Swift Neo handle all of that instead. So my involvement with Vapor, Vapor was created in 2016, as I said, February, and I started playing with it in about July of that year, a few months afterwards, kind of back in the early, I think it was about 0.4, 0.5 days, just to kind of see what was going on. And then Vapor 1 came out in September 2016. So around Christmas that year, I decided that I wanted to kind of get more involved with it. At the time, I was writing Java, Objective-C, Swift, Python, PHP, JavaScript, and I was kind of fed up with kind of switching all these different languages. I decided I really enjoy Swift. I want to get on board with it. Let's see what all the fuss is about. So I started porting one of my websites over, and I realized, well, I've got a blog on that, so let's write a blogging engine. How hard can it be? So that was December. Then many months later, I kind of emerged from the rabbit hole, realizing that writing a blogging engine can actually be quite hard. But I created a library called SteamPress, and at the time there weren't many examples of how to write kind of relatively big Vapor projects, and it kind of got picked up, quite popular, and used as kind of an example of how to write things. And then Vapor 2 was released in 2017 of May, and over the course of the rest of the year, I kind of created a few more projects, including things like Vapor security headers, which add a load of security headers to your websites, Leaf error middleware for doing custom 404 pages and things like that. And then in November 2017, I started working on the raywendlick.com book and video series for Vapor. And then mid-2018, Vapor 3 was released. I say mid-2018. It was in May when the actual Vapor package was tagged, but it took another kind of 3 months or so for the rest of the dependencies to be tagged and officially released. So why would you use server-side Swift? Because after all, there are a number of established languages and frameworks that are already out there providing it's essentially exactly the same thing. Well, the first and the most obvious reason is because it's Swift. We all love Swift. We're here at a Swift conference. Swift's a really popular language. It's growing exponentially. It's always marked as one of the most loved languages. It's really simple for beginners to pick up and can be really powerful. So why wouldn't you use Swift? If you're an iOS developer needing a backend, or let's say you're moving towards more of a full stack development process like they have at Netflix or other companies, and you need to write a backend for your application or part of your application, you don't want to go learning another language if you already know Swift. So why not use a language you know and love? It's also a modern language. So Swift has been able to basically take all of the lessons of all the other languages, take the best bits, and then throw away all the cruft. If you look at some of the more traditional languages that we have in the server-side world, like PHP and JavaScript, these have been around since the early 90s. And the world has moved on a lot since the early 90s, especially technology-wise. And they're carrying around a lot of tech debt, and they can't break things as much as Swift could in the early days. And so it means Swift can basically take all the good bits and not use any of the bad bits. It's also extremely safe. So Swift is strongly typed. It's also statically typed, which means that you get a compiler. And this will blow JavaScript developers' minds in that they can see errors in their code before they ship it, which to us is pretty normal. But if you're working in kind of a dynamic world, generally you run your code and you wait for it to break. Whereas in Swift world, you get a compiler to tell you where you've done most of the problems. And that's really powerful. And we'll see some examples of that later. And it can really make your code really safe, and it can reduce crashes. And it also means you get whole swathes of bugs that just aren't possible in Swift. If you're writing proper Swift code, you should find that your application rarely crashes. Null pointer exceptions should just not exist. Whereas in things like JavaScript, you just throw around nils like candy. So it's a very different world. But it is a lot safer, and it provides a better development environment and better application stability. So I have this extremely scientific graph, as you can see here, and we've got developer happiness on the y-axis and functionality on the x-axis. So if you're a developer, why would you pick Swift? Well, if you're writing a backend for application, you've got your iOS app, you need a backend, you'll probably start off looking at something like CloudKit. And it's got a really nice Swift API, it's written by Apple, and you can get going really quickly with it because it provides really, really good interfaces to be able to use. But you'll quickly find that there are things that you can't do that you need to do. Maybe you want an Android client as well, and then you have to kind of try and work out how you can use CloudKit in an Android client, so maybe you have to go through the web API. So what you do is you end up, okay, well, that's not good enough for me, so I'll start using something like Firebase. So you move on to Firebase. And your functionality is greatly improved because there's a lot more features in Firebase than there are in CloudKit. But your happiness kind of starts to drop a little bit because Firebase is very opinionated on how you should do things. And you also find that you start fighting the system a lot. And also, if you then add a web client as well, so you've got an iOS and Android and web client, you start duplicating a lot of your business application, business logic in your applications in your client applications, which is bonkers. You should have a single place in the server. So what you tend to do after that is you go and write a proper server application for your backend, and then we'll pick something like Node.js because that's one popular one. And you'll find that you're really productive because it does everything you want to do, but your happiness is way down because you have to use JavaScript. Now, I'm not going to bash JavaScript too much, but let's talk about JavaScript. I highly recommend everyone goes and watches this talk. It's a 5-minute lightning talk, basically about the ridiculousness of JavaScript and how just crazy it is. Here's an example that was on Reddit a while ago, and how something is equal to true, and then it's also equal to true, but you basically switch around as equal to false. And it just doesn't make any sense. And why people want to use JavaScript in business-critical applications on the back end is completely bonkers. I do not understand it, and it's my mission in life to destroy that. So back to this scientific graph. So you tried Node.js and realize it's a silly idea. So you pick up something like Vapor, and what you'll find is it's this really nice happy ground of your functionality is all there because it's a web framework. You can do whatever you like, but your happiness is really high because you get to use Swift, and the graph proves it. Obviously, if you're a business, why would you let your developers use Swift? After all, it could be a big change. Well, like everything, it comes down to money at the end of the day. So because Swift is a compiled language, the memory footprint of a Swift application is really small. A typical Vapor simple application will use about 6 megs of memory. If you look at something like JavaScript, and anyone who's tried to run Slack on their desktop and anything else knows that JavaScript hogs memory, and that's not even talking about PHP. So the memory it requires is orders of magnitude less than it is for other languages. And because you need less memory when you're running an application, that means you need less servers. And that's a direct cost benefit that you can attribute to using server-side Swift. I mentioned briefly how server-side Swift and Vapor is now kind of non-blocking and asynchronous. And because it's a non-blocking architecture, if you're writing very I/O-heavy applications, what you'll find is that you're able to handle a lot more requests per second than you were if you're writing synchronous applications. And some of the more traditional back-end stuff can be very synchronous, although they do have asynchronous parts, some of them. So because you can handle more requests per second, and also because it's a compiled language, and you don't have to run an interpreter, or you don't have to load up JVM or anything like that, you can handle more requests per second, which means you need less servers. And that's less money. So both of those things will see a big reduction in cost. There was an agency in Copenhagen and London who basically said, right, we're going all in with Vapor. We're using PHP up to now, but we're going to get rid of it and just go all in with Vapor. At the time, they moved all their application from AWS to a managed service, Vapor Cloud, and they saw their back-end bills drop by about 70 to 80%. 70 to 80%, and that's not a typo. So that's a fairly significant decrease in your costs. And it's also safer as well, which means you're not going to be getting woken up at 3 o'clock in the morning because your website's gone down. So that's always a bonus. So why would you pick Vapor? Because there are other server-side Swift frameworks out there, and there are some very good server-side Swift frameworks out there as well. Well, to start with, Vapor is very modern through and through. Vapor 3 requires Swift 4.1. It makes use of the latest language features like conditional conformance and key paths. Some of the other frameworks, because they're kind of more enterprisey, they have to maintain backwards compatibility with older versions of Swift and with older versions of the frameworks because they don't want to break things. And this means that you're kind of accruing a lot of tech debt because you have to basically make it work with lots of different types of lots of different versions of Swift. And that can be a bit of a detriment to the framework. Vapor also has a really Swift-like API. If you look at some of the other frameworks, they're kind of heavily inspired by like Node.js. And you have to take your request, create a response, set the status code, and set the body. And if you just want to return a string, why not just return a string like you would in Swift? So Vapor provides a really nice Swift API, and we'll see that later. In Vapor, Codable is everywhere. Now, some of the other frameworks have started to catch on with this, but Vapor 3 was kind of the first where it basically said the full stack will be Codable. So if you're interacting with a database, you use Codable. If you're sending and receiving JSON, you use Codable. If you're interacting with forms, you use Codable. If you're sending data to your templating engine, you use Codable. And this means you get all of the type safety that you would associate with Codable, and you don't have to worry about the kind of stringly typed objects as we would have in other languages. And so that's really powerful. Vapor also has a complete Swift stack, mostly. There's a couple of files out there that are still C, but for the most part, it is completely Swift. all the way from the database drivers, and the database drivers are completely non-blocking, written in Swift, which is very, very rare. Most web frameworks will use blocking, the kind of C blocking libraries that you get with the OS. And this is really powerful because if you're trying to debug a problem or work out what's going on, you can just set a breakpoint in Xcode and step into the Swift, into the framework, and work out what's going on, which is really powerful and really nice. It's also the most popular, so let's get the ego trip out of the way. Vapor has more stars than any other framework, any other server-side Swift framework on GitHub, and as everyone knows, that is the key to being the most successful and the most powerful framework, obviously. But it is extremely popular, and that is all driven by the community. The Vapor community is probably the biggest and most active server-side Swift community out there. There's hundreds and hundreds of active developers. We had to move from Slack to Discord because we're on a free plan on Slack, and we'd use up the 10,000 message limit in a few days. So if you were trying to go back a few days to work out what messages are gone, they're all gone. So we moved to Discord so we could get history. And I haven't worked with any other server-side, any other open source community that is as welcoming and friendly and active as Vapor is. So the biggest part of Vapor is the community, and I can't stress that enough, to be honest. So how do you deploy your Vapor applications? So, well, Vapor runs on Swift on Linux, which is basically Ubuntu. So anywhere you can run Ubuntu, you can run Vapor or Swift, and that includes Docker, so that basically means anywhere, because you can just Dockerize your applications. The Vapor team have also released or also developed a thing called Vapor Cloud, and that's kind of very similar to Roku. It's kind of a platform as a service where you basically just write Vapor Cloud deploy, and it pushes all your code up to the internet, deploys it, and you don't have to worry about managing servers or how to do deployments or anything like that. And that's really simple. So what are some of the downsides to server-side Swift? Because I've presented a very amazing view of let's use it, it's great, but we should talk about some of the downsides, just to be fair. The first one is the asynchronous architecture. If you've never used futures or promises before, you've only ever kind of done synchronous coding, especially on the back end, moving to an asynchronous architecture can be quite confusing. There's no getting around it. There is a learning curve there. But once you've got used to it, it's fine. But there is a little bit of a bump you have to kind of get used to. So it's something to bear in mind. The tooling is not fantastic. This is mainly due to the immaturity of the platform, the language. If you're trying to debug stuff on Linux, on a server-side Swift project, you're probably going to have a bad time, and you're probably going to resort to print statements. It is getting better, but for now, you're probably going to have to do a bit of fighting. And also, all server-side Swift projects use Swift Package Manager, and you want to use Xcode. Swift Package Manager and Xcode don't play very well together at the moment. It's a lot better than it was, but it's something to bear in mind. The next problem is Foundation. So we're all used to using Foundation on iOS and macOS, and that's the battle-tested 20-year-old Objective-C Foundation library. When Swift was open source, they also open source Foundation and rewrote it in Swift. It's on GitHub, you can see, but there are still a number of unimplemented functions which you may hit up against. Things are a lot better than they were a couple of years ago. A couple of years ago, you'd find most things would crash. These days, it's pretty rare, but it's something to be aware of, and you should definitely test your code in Linux in unit tests to make sure you catch any of these issues. The next is the ecosystem. If you are writing the next Facebook and you want your backend up and running in a week, don't use Vapor or server-side Swift. Because it's still very young, a lot of packages just don't exist. A lot of the kind of very common ones now do, but if you're doing something very obscure, like writing a Oracle-based database driver, it probably doesn't exist. You may have to write it yourself, but that is part of the fun. And there's not many industries or parts of tech where you can say, I wrote the first X. So that is part of the fun if you have the time. But if you don't, it's something to be aware of. And related to that is the knowledge, especially with the move from Vapor 2 to Vapor 3. If you're Googling stuff on Stack Overflow, chances are you might find some Vapor 2 answers which don't relate anymore. It's very similar to when Swift 3 came out, and you Google stuff and all the Swift 2 answers came out, and it's like, well, this doesn't make any sense. But it is getting better. The documentation is getting better, and the community are getting better at writing articles and stuff, and it's out there. So I've harked on enough, and instead of talking at you the whole time, I thought, let's do some live coding, because that always goes well. We also get to see how good the Wi-Fi is down here. Cool. So, screen there. So I'm going to create a new Vapor project, and to do that I can use the Vapor toolbox. So I basically just type Vapor new Swift Heroes, and this will clone the Vapor template, set up the project, set up a Git repository for you, and provide everything you need to kind of write a very simple API template, which you can then build on. And if this clones, we will work. If not, we'll have to do something else. I'm going to say this isn't going to work, is it? Okay, well, fair enough. So in true BBC style, here's one I made earlier. So the Vapor new clone worked, and you can see I have my project here. And then what I can do is just type Vapor xcode-y. And what all this will do is it will go and clone all the dependencies from the internet, very similar to like a pod install if you're using CocoaPods. And then it will generate an Xcode project for you and then open up that Xcode project. So, is that readable at the back? No. Let's make the display a bit better. Yeah, although it is off the screen weirdly. Oh. So I have my Vapor project here. You can mostly see there. That'll do. So your Vapor project's made up of package.swift, and this is very similar to your pod file if you're using CocoaPods, and this just defines your dependencies. This project just uses Vapor and Fluent SQLite. You then have a run module, which is just for running the app, and it basically just contains a very simple line of code. And then you have your application module, which contains all of your application logic. And the important things to note are the configure file, and this basically just sets up your database, sets up your router, any middleware, and then any migrations, and don't really need to worry about that too much. And then you have your routes.swift file. So you can see here I've got basically defined a couple of routes, and let's get rid of that. So I have a router here for hello, and it just says hello world to me. So if I build and run this, and then go to Chrome, and if I go to localhost colon 8080/hello, you can see it says hello world to me. Pretty simple. So let's write another route for say hello to the conference. It's really low down this keyboard. So if I want to do /hello/Swift Heroes, I can just write the next parameter /Swift Heroes. So that's /hello/Swift Heroes, and each parameter is another argument. And then give it a closure, which is our route handler, and basically you just return your string. So if I build and run that, go to /hello/Swift Heroes, get hello Swift Heroes. Pretty simple. So you notice how I'm just returning a string here. I only want to return a string, so why make it any more complicated than it needs to be? And Vapor handles all of the kind of setting up of the response and setting the status code and setting the application headers that you need to worry about, and you can just write your application logic, which is really powerful. So let's say I want to say hello to myself. Do router.get hello and then my name. Obviously writing everyone's name out here is going to be pretty impractical, so we want to be a bit more dynamic about that. So to do that, we can just do string.parameter. And then because it's Swift and the compiler doesn't really know what you're doing, you have to specify the return type. But then I can get that name out of the request. And then just return hello name. And then if I go to my browser, I can do /hello/Tim, and it says hello Tim, hello Alice, hello Alice. And that's just how you do kind of dynamic routing. If I wanted to do an integer, let's say I want to get the counted number of bottles on the wall or something like that, do int.parameter. Pretty simple. And then I can get the count out as well. That. So the important thing to note about this is if we inspect count, it's an integer, obviously. But in some other languages, you wouldn't actually know that. You'd have to kind of check it was an integer first. So if I go back to my web browser, I can do bottles, 99, there were 99 bottles. If I then do bottles hello, Vapor will actually handle that for you and give you a correct error message, give you a correct status code with its inbuilt error handling. And that's really powerful because you don't need to worry about any of that. You don't want to worry about any of that. And so this kind of helps you get going really quickly. So I've kind of shown you some very basic routing stuff, but let's take it up a notch and do some interaction with the database. So I'm going to create a new model or new file for a user. And I'll put that in the models directory. So I'm going to import Vapor and import Fluent SQLite because I'm going to know I'm going to save this into the SQLite database. So I'm going to create a model. And that's going to be codable. And we're just going to have an ID that's going to be an integer, a name, and a username. And then I'll just create the initializer. My typing is terrible up there. Cool, so that's my pretty simple model. So if I want to be able to save this into the database, I need to make it conform to the model protocol. So I can write an extension, make user conform to an SQLite model. Now, to do this, we need to be able to basically be able to tell Fluent how to interact with the database, what the column names are, what the types are, how to take the database data and turn it into a model. And it's extremely complicated. You just do that. I'm also going to make it conform to content, which is Vapor's wrapper around Codable to basically make it handle JSON really easy. And then the final thing I need to do is also create the user table in the database. So I'm going to need to create a migration for that. So in this migration, we need to set up the table, create the columns, set the column types, set the column names. And again, it's really complicated. You just do that. Why make it more complicated? And then the final thing you need to do is add the migration to your migration list. So you just add it in the configure.swift. And we'll save it in the SQLite database because Vapor can work with multiple databases at once. And basically, when this next runs, it will create the user table. So if we go back to our routes file, and let's create a route to create a user. So for this, I'm actually going to use the REST application, which you can just about see there. So REST is just a free, very simple REST client for Mac. So to do this, I'm going to send a post request, HTTP post request to /API/users, and then I'm going to send it two parameters in JSON, which is going to be the name, which will be me, and then the username, which will be Tim, see if I can spell. So that's what my request is going to look like, and my JSON body is going to look like that. So let's write a route for that. So we'll write a post route and just use .post for the post method, and it's going to be /API/users, and then in this we're going to return a future user because remember this is asynchronous, so once it's been saved in the database, we'll return that user. So I need to get the user model from the incoming JSON and decode that. Hopefully you should kind of get the idea now that it's quite easy, and because this is also codable, we can just use codable to do this. So I'm going to, let's use sync decode. So there's, the end. synchronous and asynchronous decoding methods, and this is because if you're doing streaming requests, your body may not be there, but because we're just sending a very simple JSON request, we know the JSON body will be there when the request is sent. So I just tell it to decode that, and then if we inspect our user, that is a guaranteed user model. So in other languages, especially some of the dynamic ones, you actually have to check all the different types. You get some kind of object, but it might be user, it might not. Because this is Swift, we know this is a user, and it's a guaranteed user type. And that makes it really powerful. And kind of it starts to show some of the benefits you can get. So I want to save this in the database, and then return the user once it's been saved. So I can return user. So I'm going to save this in the database, and then you just write save. And that's everything you need to write. And this will return the user for you. So if I build and run that, so because Vapor is asynchronous, you basically have to give it a thread to do the work on. So it needs thread to basically be able to do the save on the database. And so you basically pass around the request object as this thread. And this means that your code is all runs on the same thread for that request. So I have my request here. I send that, I get 200 OK, and I get my JSON body back. I haven't really had to write much code at all. So that's pretty easy. So if I want to get all of the users from the database, we'll send a GET request to /API /users. This one's going to return a future array of users. So to do this, I need to make a request on the database. I need to get all of the data back from the database. I then need to turn it into a user model, which, as you can guess, you create a query, and then you just simply return .all. Why not? And that's all the code you need to write. Very simple. So if I go back to rested, I'll send my request again because by default the template uses an in-memory database. So every time you run your application, you lose your database, which is really good for kind of prototyping and getting going quickly. So if I now just send a GET request, actually let's create another user just to make it a bit more obvious. So create a second user with the ID 2. And if I send a GET request, you can see I just get my array of users back in JSON. And I have had to write very little code for that. So how about getting a single user from the database? So what I'm going to do is I'm going to send a GET request to /API /users and then their ID, which is an integer. So you may be thinking, well, I'll use in.parameter and then I can use that integer to make a request on the query on the database and return that user. It's actually a bit more simpler than that. What I can actually do is write an extension again on user to make it conform to parameter. And like everything else, it's an empty conformance. And then I can just use user.parameter. And this will return a future user because it needs to go and get it from the database. So I can just get my next code catches up, users from the database like that. And that will just pull out the user as a parameter on the request. And it does all the heavy lifting for you and does all the querying. If the user doesn't exist, it will handle that for you. You don't have to write any of that code. So let's go ahead and create my user again. See, I have my user. So if I make a GET request to /1, I get my user. If I make a GET request to /100, I get a 404 with an error message. You don't have to do any of that. It does all that for you. Really powerful. So the final thing I'm going to show you is writing a bit of a search function for searching the users. So it would be /API /users /search. This is going to return a future array of users because there could be all the users it finds. So to do this, I'm going to send a GET request to /users /search. And then I'm going to do something like term equals Tim, something like that. So I'm going to use an HTTP query for that. So to get the query out, I can do that. I'll get the string at term, which is what I called it. Otherwise, I'll just throw a bad request or something like that, like a 400 status code. I can then return a query on the user database, and I just need to import Fluent at the top for this. And then I'll just filter everything, all the users, let's say name equals to search name. Done. Would help if I wrote guard. And that probably... Yeah, what am I doing here? That doesn't work either. This is why you never do live coding. Oh, I know what I've done. Okay. Would help if I remember my code. So I'm basically going to say get the string at this term. Because you need to put, that's just the signature, as I should probably remember. So important thing to notice about this is, again, this is a string. So if I say, well, let's get an integer here, I'll actually get a compile error because it knows it can't compare the name, which is a string, to an integer. And that's another compile time check that you get that you wouldn't get in other languages, which makes it really powerful. So let's just demonstrate that to prove my code does actually work, because I don't actually trust myself after that. So we'll send a post request to API users and create a user. Let's create a couple of users named Alice and then one named Tim. So see, I have 3 users in there. Send my get request. You get all 3 users, and then search equals Alice, and you get the 2 users named Alice. And that's kind of how you do search. So that was the demo. So in that demo, I basically went through and created pretty much a full CRUD API in a space of about 10 minutes, writing very little code. So to kind of recap, we saw how to do some basic routes in Vapor, and we saw how to do some dynamic routing in Vapor as well, using the parameter type. We saw how to create models. So we had a very simple model, and we can then write extensions to make it conform to model and content to help us interact with the database. And we then saw how to write routes to basically save and retrieve our models in the database. So some caveats before we kind of finish up here. What I just showed you was a very simplistic, ideal view of Vapor, a very simple hello world that probably, if you're writing a proper application, won't necessarily all apply to you. In that demonstration, I only wrote a single user codable type. In a real application, you will probably write more than one codable type, no doubt. You'll have a representation for saving the database. You'll have a representation for presenting as JSON in your API, because if your user has a password, you don't want to give that password out in your API, obviously. So you will write a lot of codable methods, but if you're kind of following domain-driven design, this is kind of expected, so it's not necessarily a bad thing. And you get all of the type safety from codable anyway. I wrote an empty conformance to migration. In a real app, you're probably going to want to write your own migrations, especially when it comes to the point where you need to change your database in production. You'll write another migration. At that point, you should definitely manually type out your migrations. Otherwise, you're never going to be able to recreate different versions of migrations. So it's something to bear in mind. It looked like Vapor wasn't particularly customizable, so my model only had an ID that was an integer. If you want to change that, you can, and the database will still work. So you can customize it pretty much extensively. So it makes it pretty powerful, even though it might have seemed very simplistic there. However, if you are writing very complex database queries, there is a chance that you're going to have to dip into some raw SQL, because there may be some things that Fluent doesn't yet support. So you might have to write some raw SQL, but Fluent supports that, and you can use Codable to decode all your data anyway once you get it back. So be prepared for that. So, where to go from here? Shameless plug time. There's a Vapor video course on raywendlick.com. The first part is free and that basically does everything I did in that video. Just be warned that it was filmed back in January, February time, when Vapor 3 was in alpha, so there are some things that are out of date. There's a gist on GitHub that contains all of the changes, but I am re-recording this right now, and it should be out hopefully the end of the month with all the updates. There's the Vapor book, which is available from raywendlick.com. I've written this with the guys who write Vapor itself, so it's me and the core framework team as kind of the unofficial official guide to Vapor. Check that out. It's completely up to date. We're writing the second edition at the moment, adding in 8 new chapters, I think, to basically pad it out a little bit. I also have some free copies to give away today, so if you're interested in that, come find me. I've got 2 or 3 copies to give away. Unfortunately, they haven't arrived from the publisher yet, but we can work something out, post it out to you, or we can get a digital copy. And then if more than 2 or 3 come to me, we'll have to do some sort of draw and work out how that works. So, thank you very much. That's everything.